Okay, I'm going to start talking about section 3.6, Algebra 2 Honors, solving radical equations. An equation has an equal sign. A radical is a square root or usually a fractional exponent. Okay, again, you want to isolate the radical, then raise it to the appropriate power to eliminate the radical, and then solve the equation. So I'm just rewriting what I have here. This is the exact same equation. To get rid of a third root, you raise it to the 1/3 power. I'm sorry. The third root is a 1/3 power, so you raise it to the third. To get rid of a third root, you raise it to the third. If you do that to one side, you have to do that to the other side. The third root and the third power eliminate each other, and 3 to the third is 27. If you subtract 7, it makes 2x equals 10. If you divide by 2, you get your answer to be x equals 5. You can put it in and check. 2 times 5 is 10. Plus 7 is, it should be 20, right. That's why good thing I checked because I had the wrong answer. If you subtract 7, you're going to get 20. And if you divide by 2, you get 10. So that's better. 2 times 10 is 20, plus 7 is 27, and the third root is 3. Again, you want to isolate the variables. So the opposite of isolate the radical or the variable. This is a radical because of fractional power. So the opposite of multiplying by 4 is to divide by 4. That gives me x to the 2/3 equals 9. I'm just rewriting it for your benefit. To get rid of the exponent of 2/3, you're going to raise it to the reciprocal, the 3/2 power. 3/2 power. And the 2/3 times 3, power to a power you multiply, that makes the exponent 1. Right now I have 9 to the 3/2. Remember, it's power over root. So the square root of 9 to the 3rd power. That makes 3 to the 3rd, or 27 for example 3. You can check it because if you put in 27, the third root is 3 to the 2nd power is 9, and 9 times 4 is 36. So it does actually work, and I'd really recommend you plug them in and try to check them if possible. Okay, now let's look at example 4. We want to isolate it, so I'm going to add 1. If I add 1, that makes a quantity of x plus 2 to the 3/4 equal 8. Now I want to get rid of that 3/4 power. A power to a power, you multiply exponents. So if I want to raise it to the reciprocal power, if you do it to one side, you do it to both sides. That makes it, when you multiply your exponents, it makes it to the first, which really is just x plus 2. Again, it's power over root. I always recommend you do the root first because it makes the number smaller. The third root of 8 is 2, and 2 to the 4th is 16. So when you subtract, you should get your answer to be 14. Let's check. What is 14 plus 2? 16. Fourth root of 16 is 2. To the 3rd power is 8. And then 8 minus 1 is 7. So again, you can plug them in and check them. I highly recommend it because you might end up with what's called extraneous answers or solutions. Ones basically that are not valid solutions. I think those will be coming up in the next couple examples. Okay, example 5 is slightly different. To get rid of the square root, you're going to square both sides. So let me go back and rewrite it so I can use that for checking purposes. So I'm just rewriting this. To get rid of a square root, I square it. And because of the radical's already isolated. To square this, you square the first, twice the product, and square the last. We spent some time doing that in the early chapters. If you have to write it out twice and FOIL it, feel free. But you should start learning the rule. To square the square root goes away, leaves me the radicand, the part under the radical. I'm going to subtract 7x, which makes this minus 5x. I'm going to subtract 5, which makes this minus 4. And I did that so that I could make it equal 0, right? I need to make it equal 0 so that I can solve the trinomial. Sorry, apparently I wrote this wrong. It should not be 7x plus 5. It should be 7x plus 15. So that 5 right there really is a plus 15. And plus 15, when I subtract 15 from a positive 1, does that make this into a negative 14? So that, sorry about that, I had it written wrong. It should be 7x plus 15. How does this factor now? Factors a negative 14 that add to negative 5. That'd be a negative 7 and a positive 2. What makes each one of these equal 0? The answer would be x equals 7 or x equals negative 2. The problem is only one of them works. If you put in a negative 2 up here, what's negative 2 plus 1? Negative 1. A square root can never equal a negative. So I know that one does not work. We can try and put it in. If you don't believe me, you could try to plug it in. What is negative 2 plus 1? Negative 1. If you take 7 times negative 2, you get negative 14. Negative 14 plus 15. So that makes negative 1 equal 1. That's not true. So that's what I'm talking about, why you need to check your answers. Sometimes they'll all work. Sometimes only one of them will work. Okay, after example 5, we're going to look at example 6. Remember, step 1 is isolate the radical. There's a problem here. This radical's isolated, but this one's not. So you can't really isolate a radical to start this question. Okay, I rewrote the question. I'm going to square both sides to get rid of a square root. On the right, no problem. I square the square root, it goes away. However, on the left, when you square the first, what do you get? X plus 2. You square the last, you get 1. Twice the product in the middle would be 2 radical x plus 2. So I still have a radical in this problem. That's the issue. And I need to somehow get this radical now alone. 2 plus 1 being this 3 here. Okay, there's some confusion, so I'm going to redo this part on the left here. When you square a binomial, you square the first. So if I square this, that means the square root goes away and I'm left with x plus 2, right? I square the last, that's plus 1. Now, I do multiply these and double it. What's 1 times the radical? 1 of the radical. And then you double it, gives you 2 of the radicals. Now all I'm doing is combining the plus 2 and plus 1 to call it a plus 3. And now I'm going to try to get the radical by itself by subtracting x and subtracting 3. If I subtract x and I subtract 3, that will help me to initially isolate this radical on the left. And that gives me a negative 2x. Opposite of multiplying by 2 would be to divide by 2. And I already know, what do I have here? No, I guess this is right. Is that negative x? Is that correct? Those 2's cancel. Now, I have my radical isolated. How do I get rid of this radical? Square both sides. That gives me x plus 2 equals a negative to an even power is a positive. Make it equal 0 by subtracting it over. Factor it. Find find your solutions. Either one of these will work, both of them will work, or neither one of them will work. How can we tell? By plugging them into the original. So I'm going to take my original and I'm going to start plugging these numbers in. 2 plus 2 is 4. Square root of 4 is, I'm checking 2. 2 plus 2 is 4. That gives me a 3 on the right. However, if I put in a 2 here, I think I get a 1. Let me verify. That gives me a 2 plus a 1 is a 3. So I don't think that one works. Now we're going to try the negative one. What is negative 1 plus 2? 1 plus 1. On the left we have a 2. If I put in a negative 1, and I put in a negative 1, just like I did over here, I get the square root of 4, which is 2. That one does work. So the only valid solution is x equals negative 1.